In this video, we are going to look at a very important postulate in plane geometry, the segment addition postulate, and we are going to use that in a proof. So the segment addition postulate states that if you have points x, y, and z that are collinear on a line, that point y must be between x and z, and this gives us the idea that the segment xy plus yz is going to be equal to the segment xz. And so I have a diagram here in a given stating that AC is going to be congruent to BD. And then we are going to prove from that statement that AB is going to be congruent to CD. And I don't know if you can visualize in your mind, but if these were wires and this segment is connected to this wire at this point and this segment's connected to this wire at this point, they would kind of slide across each other. You can kind of visualize that as these outsides change, that's changing this gap in the center. And so there's some differences in the way that you can establish what your diagram looks like and still really be conveying the same kind of information. So this is my diagram. It's probably a fairly decent diagram, but we don't want to assume links other than the ones that were given and then work towards proving these other links. So right away, the first line of our two-column proof is going to be the given that AC and BD are congruent segments. And then to be able to use this property, which involves some addition and equality, we want some algebraic manipulation. So we want to switch from congruence to equality, and we can do that easily through the definition of congruence. So we essentially on this side are just rewriting this with an equal sign. On this side, our reason is definition of congruence. So we have segment AC is equal to segment BD by the definition of congruence. And then I'm going to start using this new postulate to make some statements. So I can say that AB plus BC is going to equal AC. So I'm going to do that. And we're using this postulate, the segment addition postulate. And I'm going to do the same thing over here. I'm going to do BC plus CD is equal to BD. And that is the same reason. It's an angle addition postulate. At this point, we have the same segment in two different statements. So there might be a way to reconnect these through that common segment. The other thing that we have is that this segment and this segment are given, stating that these are congruent, or with our rewrite that they're equal, so they can also be immediately connected as this is equal to this. And so that is a substitution. So there's a couple connections here that we can make. We are going to take our given and use it to rewrite this statement. So I'm going to write that AB plus BC is equal to BC plus CD because of substitution. And then once we have this, I can eliminate BC from both sides by just subtracting that segment from each side. So we could say this is the subtraction property Now I have AB equals CD, and I'm one step away from the thing that I'm trying to prove, which is that AB is congruent to CD. And to switch from the equals to the congruence, I'm just going to reuse the definition of congruence to switch those signs. So I'm going to go AB is congruent to the segment CD, and that's definition of congruence. And at that point, I have, well, as my last line here, what I was trying to prove. So you can put your completion mark there. We have demonstrated what we were supposed to demonstrate. So this proof is complete. Comment about segments. There's a theorem that tells us that we have reflexive, symmetric, and transitive properties when it comes to segments. And what that is telling us that for a segment AB, it's going to be congruent to itself. If you know something like AC is congruent to BD, and then you know another statement that BD is congruent to some other segment, you can bring those together to say that AC is congruent to that last segment as a transitive property. And then you can also reverse this order by symmetry. You can say that AC is congruent to BD, and then symmetrically BD is congruent to AC. Each of the three big statements there, the idea that you have reflexivity, symmetry, and transitivity, should all be proven, since that is a theorem, and theorems require a proof before you can use that. So try that on your own and see if you can come up with proofs for those ideas. You can also get that AB is congruent to BA. Instead of measuring from left to right, you can measure from right to left. Cheerful calculations.